So in this video I will show you the porting of the mechanisms with the caching, with building offline to Alpine. In previous video I used an Alpine distro that I hacked very quickly in one of the meetups, or before or after one of the meetups. I showed something like how to add hardware to an emulator with alpineos, how to add the firmware files for like a network adapter. It was, I think, a Wi-Fi and Bluetooth adapter, something of Realtek, and all kind of things. But the rootfs itself, every time we built it, if we did not just say, okay, don't rebuild rootfs, then it would need to go to the network, because that's what APK does. The package manager of Alpine, by default, it makes the packages ephemeral. That is, it downloads the packages and don't keep like the caches, as opposed to Debian and Ubuntu, for example, and Red Hat and SUSE and everyone. So to make things buildable and reproducible offline, and very much like the Dockos files, I just copied the mechanism for pscg-Dockos. So I'm not going to go over everything. I did not finish cleaning it up, but I think I did a job that is okay enough. I tried to make it like very easily comparable for you to look at, and also for me to look at. And the way that I'm going to build things, I took like the temporary build one arc file that came from the build multiple build all arcs script for QEMU, and which from there I derived like the example for like building the AM logic one as well. So I actually went and took like this file. So look at the differences between the file, the one arc and the other one. No differences other than the build as build kernel. It was just a shortcut to not build again. It would be true by default. Enable graphics, because I said before that only if it's PscgBuildOS I will do enable graphics, but then I made like a script that enable graphics also set the parameters in QEMU to provide like the DRM devices, and it also builds the kernel with DRM support. So instead of just specifying a lot of things, then I say, okay, enable graphics and use the same wrapper script. So it's useful. And the distro that I build is build the alpineos buildable, we said before also. And this is something new: export config psg alpineos post build clean apk caches, true, which is exactly like config psg-Dockos post build clean deb caches, which means, hey, do we want to keep them on the final system image or not? And there are reasons for this and for that, time versus space, as mentioned. So this is the file that is being used. So like if we build it, then like a lot of things happen. We don't build around this right now, but we can see, I mean, it's too fast. I don't know if, because we can see that there's a lot of installing. You can forget about the opening, blah, 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 blah. I'm only using my own caches that I built. So I added like caches that I built, and I have like a mechanism that is very, very, very similar, like with the fingerprinting to the other, to the psg-Dockos one. So if I now go and I created like a little storage device here temporarily, and I run, let's do this command line equal, let's do wait for removable media and installer A only equals true. Then here I have graphics. You see I have DRM. Maybe you could hear that like we have the installer. Maybe you can hear like a sound now. And yeah, I mean, if I, you know what, it's so fast that I will do the reboot and we'll see that we have, okay, it was so fast, like the sound from before didn't even stop. But this is like an AB, sorry, oops, like I did not modify the command line. So what I wanted to say, it will also be super fast. So this is like the AB update. This is like the OTA update that like we would normally have, and it already finished. So yeah, it completed the installer, and then it comes like to the command line. And here I would have command line that I did automatic root here, and I will also have this fellow here, okay, which is also nice. And let's see, the pscg-OS release, that's what I will have here as well. And if I look at the different file, I have my OTA that is like running, and we have droppers. So I could go from external. I made like the slurp backend for QEMU, not a tab device, but I could theoretically and not so theoretically go ahead and SSH like my local host. And here I am like on an SSH, okay? And before I just did BNSH, but here I actually see like my host name. So let's see how these guys happened. By the way, some of the things we're just doing by populating this, for example, the serial device that we have here. For example, HVC, that if you see this after the Docker videos, and this is the order where I upload it, you can see that this is how it's being done. The host name is set only if we do like bin host name, it's set like from the file, otherwise it takes it like from the kernel. And we have like this nice one. So we do have RC service, okay, and RC status, okay, and essentially it's because we selected the package manager that is OpenRC. So having said that, we see that we have a system. Let's go and quickly look at the mechanism. So I try to make things as similar as possible to the rootfs, to the PscgBuildOS ones. So I will not go over everything. I'm just giving you like giving you the topics to go on. Here I will add another video, okay? So let's do that. I never do when I record it, but yeah, okay, yeah, sure, why not? Video recorded Jan, where is 29, 26, and I will even fix this. Okay, all right, that's fine. Wow, it's been almost 2 years. All right, but the important thing here is that the add some packages for Alpine, I no longer call it, so I can remove it essentially, okay? I commented it out, and I'll probably even remove it. Modify it for Alpine, I no longer need it as well, because I do things in another place, so let's me delete it. It doesn't do like any error here, so it's like empty, so I'll delete it as well. If you add some packages, I also don't need it, but there were some nice things here. I will clean up other things that were run before and now are not needed. Okay. I'll also get rid of this one, and I will also get rid of this one, so it will be cleaner when I plug it. So you can see that we have more layers here, from the layers here, psg, alpineos, init, network minimal, and so on and so forth. Okay. I don't need this, I don't need the archive utils, there is enough for a busybox, so now it's cleaner and nicer. You can see it in the post pass, I delete APK index, whatever, it's like the Debian caches and the APK, which are like the Debian packages themselves. And it still like requires a cleanup in a way, but some things here are not really needed. I modified some things. And I say the bootstrap, it's not really the bootstrap. I made like the bootstrap equivalent for the fast that does all kind of things. It still takes a tarball and still does similar things, and let me go over it. Now before that, for the pre-pass itself, it calls the script, the bootstrap equivalent, okay? And another thing that it does, if needs be, is build caches, okay? So this is, I kept it because I wanted to delete it from the other file. yeah, it's not relevant. And we have like the build caches that actually actually it could be done also only in the bootstrap. So this is unnecessary as well. When I think about it, it's probably copy paste from whatever was in pscg-dockos. So we also don't need this function, although the importance here was to show mounting and unmounting of like of a TMP and creating like the device node for now, because there was something with the speed, perhaps in other architecture, maybe also with x86 when doing like the very first download. So once we have things cached, it's less significant, especially since we're not going to install too many packages, but yeah, that's fine. So the build caches mechanism, essentially we have the same mechanism that we look at all the layers that we provide, we look for the config files there. In Alpine, there is no etc resolve conf by default, so we add it. And then we have like a work D where we install everything, where we download everything essentially. And we have the cleanup there. And this is and we have like a state instruction file where we want to invalidate or not. And this is where we do like the things. So there is a mechanism of caches that if we don't find what we need in the rootfs target that we want, then we're going to do like everything. Now, so we have like a fetch and unpack that will just get a tarball, and it will also get the and it will unpack it, as opposed to the bootstrap. Here we download the tarballs that we generate. So essentially, I'm not going to go over everything, but just a reminder like of the logic. So the logic would be, we check for an existing system. We have like a marker under opt to say, hey, we did it, like in Debian with the bootstrap. I will call it the bootstrap, even though it's not the bootstrap here. We unpacked, we did what we had to do. If it's there, then all good, no worries. Otherwise, we're going to look at the packages in the caches, and if we don't have like any of them, then we're going to go and essentially we're going to take care of this. Okay. So basically, sorry, that's not what I wanted to look at. So check for existing base system. It will look for like a particular file. I didn't want to cover it, so I'll just cover it like very fast. What we want to see is where the caches are. This is what we want to look at. The unpacking itself of the bootstrap thing is going to be here. Sorry. These are definitions just like with the kernel and uboot and busybox, like where we have a tarball. So this is where we take it from. And we have these files. So we have like the fetch and the unpack will be like to the cached base rootfs here. This is like the cache, the bootstrap one. And the caches will start building from there. Okay, so this is why I started like we did the bootstrap. Caches are built after we have initial things, so it's actually correct. So where the definitions are taken from, so essentially in tools there is a script that gets like the series and the version, and it will populate all the SHA-256 sums and the file's URL in another script that so we can copy it or directly redirect the output of it to this one, which will be the mini rootfs upstream. So I did not type it by hand. I made like a loop, and we have like an adjustment for each architecture, and this is how it will look like. Okay, and these are like the list of architectures that are supported. So it fetches and unpacks it, and we set it here. So build caches, it will look, I think I already like looked at it like very quickly. There is like in the there's a working directory, and then there's what we have more. So important thing, how do we create like the caches in the working directory? So in the working directory, if we want to take like the so-called the bootstrap thing, and from there we want to root to it, and then download the packages. We do the same thing in pscg-dockos. So here we use like the Alpine package manager, which is APK. We update, we must get some things from the internet, and then we fetch packages according to all the packages that we had recursively. So that's like what we have. Now here we have something where we delete previous stuff because we don't really need it. We're going to generate another cache. APK index here, dash output, APK index blah blah blah. Usually you would have it like under architecture, but this is less to type. And then everywhere else where we want to do APK add, which is the equivalent of the package install, or like a APK or apt install, we will be using this one, and it's being generated like this cache by all the APK that we downloaded in the previous step. So from this we can learn how to work with packaging in Alpine, because as I mentioned before, it's ephemeral. And other than that, at the caching step, the logic is identical to what we would have in Debian. So this is nice. There are a lot of things here. A lot of things are also copy pasted, and there's the architecture adjustment. Here it's a little bit different because the names are different than the names in Debian. Like in Debian, for example, you will call x86 64 AMD64, and here you will call it x86 64, the name of the tarbles there. So it's good, we have it, it's nice. Let's look at the build distro. So the build distro, it's going to, about this function forget, I keep it just like as a reminder, but the important thing is that we have like these layers that we add, okay? So let's look at some of them. And before that, we do like the building of the caches. This is like the basic, the bootstrap, and then we have like the build caches out of it. And if need be, we go and we copy like from the rootfs directory over there. So let's look at it now. So this is the cached rootfs here. It's not what we are interested in. What we are interested in at the end of the day is after everything, the bootstrap finds itself in the rootfs here. So there are several things that here, like if it already exists, we go there, and then this is where we do like our modifications of the etc or stuff like that. But prior to that, we're going to actually go and make sure that the caches also find themselves there. So it's all good. Everything is good, exact same mechanism as with the other one, as with pscg-dockos. So let's look at some of the layers that we add here. So for example, for init, we're going to look at the list of init frameworks, and then we're going to set them. So if there is busybox init and not OpenRC, because it doesn't come by install by default, we're going to do all kind of stuff like replacing the terminal in the get ety lines in etc init tab, or adding the OTA update code. You've seen it in the busybox ones, or forcing like the host name. We saw it right now where we all of these actually when I showed you like the running system. So this is fine. This is why we could have like the API update from the user space, because it exists, and we can also upgrade it like to Debian, to pscg-dockos. On the other hand, we also have OpenRC sh. Now OpenRC, it also includes this one, but like the Dockos, it goes and it sources all kind of packages. So we source like the packages list, that in this case would be OpenRC init. It's exactly the same mechanism, only different like variable names. And here look what we do: APK add, local APK flags, local install packages, which are the ones from the file. But the files, the flags, somewhere they are written, and they are like with this cache. There it is. Local APK flags equals blah 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 blah. Okay, so this is what we have. We could put everything like in the build config. I just didn't want to risk it. I will move it later, like after I test more. I mean, it's working. I tested enough offline and everything. So everywhere we have like this APK flag that points to the repository that we had. If the caches creating script doesn't have local APK flags, then we can use it. Now, no network is to not access the network, and allow untrusted is because if we make another index, then it doesn't trust us, even though we made it. So you know what? Let's quickly look if there are APK flags. They're not supposed to be one, and then I will just move them to the build configs. And there can be like a common build config, but I don't have time to test it. So maybe one of you want to contribute to it. Where was it? Yeah, so build caches. Yeah, it's safe to just move them to the config. Okay, so back to our example. So in our example, let's see where we were. So this is the network. I wanted to start with the init, right? Yeah. So I'll do it. I mean, why not? So we make like the default terminal Linux and not a VT102. We install the packages, and that's all that we do here. So I will also do this one. This is how it will not interfere with anything, and this will be just fine. Another layer would be, so sorry, let's go for the, so we do like the sysv init stuff. Init tab is also there, so it's fine. So this is perfect. Okay, another layer would be network. There we have curl wget, we have it by default in Alpine. We have dropper, dropper SSH, and dropper SCP. For the SSH, we already saw that we have like an SSH server. So this is like what we add. I'll also add this one. I could add it common for everything, but I'll just add it like this. And the add layer itself doesn't do much. It just installed everything. Okay. So that's perfect. It's all good, and we're happy. Another one was, forget about the update D, no. So it was a network minimal, because I don't copy it. So it was the root password. So it populates the etc release file, that's what you saw, PscgBuildOS, and the version, and so on and so forth. And we call a script for setting all kind of things. So this is how, I mean, we can also install bash, but by default there will be sh. So I just did it like this, because I didn't decide if I want to use bash or not. This is a default username and password, but we can also just delete the password, which is equivalent to removing anything that looks like a hash, which is like one thing in the line that says root in etc shadow. We also write a simple message of the day, and then we do like these things that I explained in millions of years ago in some videos. And of course I also explain these things like in the classes when we do the mini Linux. Depends of course in which class. So I do it in the Better Linux class. It's like your first exercises of making sure that we can start a course. And then I demo on things that look like this. So we replace etc issue and issue net if it's like for SSH. And here this is where we enable for dropper in RC. If it doesn't exist, nothing happened. I mean, all good. This is where we are going to put like the making root connect if we want to. Okay. So the parameters are as follows. The default is port 22, so it doesn't really matter. We have here -b mean allows blank password, and -r means they create like the key materials if needs be. So that's fine. There is another thing. It actually needs to have an Etsy network interfaces, like the service for Dropper. It insists on it. So we say, okay, fair enough. And we don't really need it, but we add like the configuration file, and we add Dropper to that. That's perfectly fine. Okay, we could also do it in Initab, which is also fine, and we set like the hostname. So this, we finished like with this one. And the last one would be common. And common, again, we have like the local APK flags, and we just install some packages. And these are the packages that we install. We have here, at first I had Vim because I copied it from PscgDuildOS, but I removed it because it weighs more than all the operating system together. E2FS progs gives us some of the E2FS prog tools, but Tune2FS, it didn't include it for whatever reason, so we also installed E2FS progs extra, and file, and util Linux, and we just installed it. And this summarizes everything, including everything that we do in this distro. And then we have this wonderful distro with the OTA, with the flashing, with everything, with caches, and we also learned how to work like with the Alpine cache system while working on it. So on the same concept, you can go ahead, take this, and maybe clean up if you want to, because probably have some things that I should also clean up from pscg-dockos, and then you can use additional package manager and use additional things. So the Alpine is no longer hacky, and you actually know how to do it and how to use it if you want to upgrade to the next Alpine version whenever that one comes out.